Okay, well, I see it's the top of the hour, so I think we can go ahead and get started with this session. Can I just confirm that everyone can hear me?
Yes.
Great, thank you. So welcome everyone. Welcome back to BELIV. This is paper session number 3. We have actually 7 papers in this session. This is just the first 4 on this slide, and I'll give you a quick preview if I can. Yes, here are the other 3. So this will be a bit of a marathon paper session for BELIV, and I want to just remind you about the overall schedule as we're getting started here. So it'll be 7 papers in this session, and then we'll have a break, and then the last session of BELIV, and that will include in the second half a breakout opportunity. So we'll go to some Zoom breakout rooms and be able to have discussions. So you'll have a chance here to post some questions to the authors, some quick ones, and then we'll use the same approach of being able to follow up on Discord if you like, but then also save some of your thoughts to discuss in the breakout session for that will sort of encompass these 2 afternoon sessions of BELIV. Okay, so 7 talks for you today, and we've got some new attendees and new authors, all presenting very exciting work, and I'm really looking forward to hearing them talk and to being able to bring all these discussions to you all. All right, so let's see. Our first speaker will be Antonia Schlieder, and talking about the role of metacognition in understanding deceptive bar charts. And I'm going to see if we can roll that talk now. Oops. Okay, here we are. Please enjoy.
Hello, and thank you for attending my talk from wherever you are on the role of metacognition in understanding deceptive bar charts. I'm Antonia Schlieder from the Heidelberg University and will be presenting joint work with Jan Rummel, Peter Albers, and Filip Sadlo. Bar charts and visual reasoning tasks on bar charts, as shown here, are commonly used as examples to better understand how we read and understand visualizations. A well-known source of deception is the truncation of the y-axis. For example, recent studies investigated under which circumstances these cutoffs can exaggerate perceived effect size. In our work, we study reasoning strategies, and in particular, changing strategies when working with deceptive bar charts. In my talk, I want to share with you 3 main ideas. First, an accidental finding. We saw that accuracy in the visual reasoning task improved even without feedback. Second, a possible explanation for this learning without feedback, and that is metacognitive processes. Thirdly, I will propose a simple instrument to measure metacognition and present data that indicate that metacognitive processes may be responsible for the learning effect. Here you can see one of the reasoning tasks we used as a stimulus. The chart shows how the value of a stock changes over a month. When solving tasks with such deceptive bar charts, we were expecting that participants would either be deceived by the axis truncation and always fall for it, or they would know to keep the axis scaling in mind and always answer correctly. However, in our experiment, we found that most participants actually improved in accuracy over time, even without being given feedback on the correctness of their answer. We also found that some participants reported changing their reasoning strategies while working on the task. A factor that is known to trigger such learning without feedback are metacognitive processes. And since metacognition, or thinking about thinking, has been rarely considered in the area of visualization, I will briefly introduce it here with an example. When we work on a difficult task, such as taking an exam, we are constantly aware of how difficult this exam is, and maybe even how much of it we believe we can solve in the remaining time. This information is called meta-knowledge. But metacognitive processes not only continuously monitor, but also control our thinking. And this meta-control activates the selected reasoning strategies to help us solve the task correctly or more efficiently. We want to look at these two variables, meta-knowledge and meta-control, and their role in visual reasoning, which raises the question of how to measure metacognition. Online protocols, such as thinking aloud, would not work on the very short timescale of our task. And while there are established instruments from research on self-regulated learning, such as the Metacognition Awareness Inventory, they have items that are not really applicable to visual reasoning. Hence, we designed our own minimalist two-item instrument that, similarly to the MAI, assesses the two components of meta-knowledge and meta-control. Participants are first asked if they use a strategy to solve this task and to describe their strategy. This answer is coded for meta-knowledge. They are then asked if they change their strategy and to describe this change. And this is our item for meta-control. We tested our instrument and the influence of metacognitive processes on visual reasoning in an experiment with 54 participants. After a brief training, each participant completed 9 task blocks, interleaved with 8 distractor blocks. An example of a distractor would be a non-deceptive trend detection task. And each block consists of 3 trials of the deceptive bar chart task. After completing all blocks, the participant answers the 2 items of our instrument in an interview. We measured if the number of correctly solved trials per block changed over the 9 task blocks. And overall, we found, through a multi-level analysis, that there is a significant curved linear trend in performance improvement with increased time on task. This alone is remarkable since participants, as mentioned, are not told if their answer is correct or incorrect, which means that there is no external trigger for them to change the way they approach the task. Looking at the coding of meta-knowledge and meta-control reveals how metacognitive abilities relate to performance over time. Our analysis shows that there is actually no significant change in accuracy for the 11 participants without either meta-knowledge or meta-control. However, we observe a significant linear trend in performance improvement for the participants who report some metacognitive processes or all. And the group with both meta-knowledge and meta-control also performs best overall. Altogether, these results support that learning and visual reasoning relates to metacognitive processes. To conclude, I want to briefly highlight some implications and directions for future work. First, we think the ease at which a visualization supports the correction of reasoning strategies could offer a new quality criterion for visualization design. And since our experiment shows quite pronounced differences in performance between the groups of reasoners, we also propose to add metacognitive abilities to existing models of individual differences in visualization. When using our two-item instrument in an experiment, it would be interesting to add items on retrospective judgments of confidence or to code the valence of strategies as well. And then lastly, we believe that metacognitive abilities have the potential to help decide when and how to present a user who's exploring a visualization with some form of guidance. That's it. Thank you for your attention. And if my talk has sparked your interest in metacognition in the context of visualization research, please get in touch. I'd love to discuss it more.
Excellent. What a really inspiring talk. I think this is fascinating, Antonia. Thank you.
Thank you.
We do have time for some questions, so I'll start off with one. I noticed just as you were summing up, you were talking about one direction is visualizations that support strategy corrections, and I thought that was a really interesting idea. I wonder if you have any sense of how that might come to be implemented? I mean, would it just through prompts or something built into the software? I don't know. I'm curious about your thoughts.
Yeah, I mean, there's a lot of potential for this to be interactive or adaptive in some way to the user. We've been looking into like signaling and guidance systems. I also see it as a metric for static visualizations, especially when we have an A/B comparison or a baseline where we could see here we not only measure how well users perform, but also if there is a strategy change or if this like learning curve is steeper. That's what I was imagining. I think there might not be any sound. Oh, okay.
Okay, maybe it's okay. I just saw that alarming text as well. Okay.
Yeah.
Great, thank you. Remember everyone that you can post questions both on Slido and on Discord, and we will pass them onto the speakers here. Great. Antonia, here's another short question for you. How did can you tell a little bit more about the instrument you developed, which I loved how you said this is, just a 2-question instrument, very minimal. And then, and I think you said that you employed it in interviews. So did you follow up with people? Was it almost like a focus group style, or interview style methodology where you would pose that initial question and then just sort of drill down?
Yeah, of course. So it was semi-structured in the way that, of course, if people said they didn't use a strategy, we wouldn't really ask them if they could describe it. Some people had a hard time with the term strategy, but surprisingly, most people could give some answer, because we thought maybe for this kind of trivial task, people would think, oh, a strategy, that's really like high level, but yeah, we got some good descriptions. But we are also looking into maybe making it a closed form item, but you would have to know the task quite well for that. So for this task, I think we could like ask a closed question as well, but yeah.
Yeah. Well, it's really interesting. I find that when developing tasks for user studies we run, I think this is essentially what we do in trying to refine those tasks as researchers. And but I don't think that we very often ask our users to reflect on it. So I think this is great. Very exciting work. Well, congratulations, and let's move on to our second paper. Let's see if I can. Well, actually, Matthew, why don't we have you go ahead and you can begin to share your slides with your title. Great. Okay, so let me introduce the next speaker. Matthew Berger will be talking about the visualization judge. And very excited to hear you present this position paper, Matthew. Why don't you take it away?
Thanks, Daniel. Yeah, so my name's Matt Berger. I'm at Vanderbilt University, and this work has been done in collaboration with Shusen Liu, who is at Lawrence Livermore National Laboratory. So this is a position paper. We're exploring how we could potentially use multimodal foundation models as a way to guide visualization design. So to motivate what we're studying, if we consider how designers, so humans, create visualizations, often when they're presented with a data set and a particular task that they want to satisfy, they'll conceive of a space of potential visualization designs. And often what they're thinking about, they're considering, visual perception when they're within this particular space of designs. And in particular, they're thinking about whether certain visual patterns would be appropriate for the task at hand that they want to address. Now, with the predominance of large language models, we can do similar things in prompting a model to give us a collection of visualization designs for a particular data set. But large language models are limited to reasoning over text. And so they don't necessarily think about visual perception in the way that humans might. And so its ability, large language model's ability to reason about designs is going to be based on whatever kinds of lessons it's learned from design principles and guidelines that it's been. So it lacks this notion of visual perception. Now, in contrast, if we have a particular task that's presented as well as a specific image of the visualization intending to satisfy that task, then we can look towards more recent multimodal foundation models as a way to both critique and give guidance on what would be a particularly good visualization for the task at hand. And so here, in contrast with a language-only model, a multimodal foundation model can hopefully better explore the design space of visualizations and understand for this particular task and a given image, whether that particular image is going to be addressing certain kinds of visual patterns that we would like to see. For instance, taking a bar chart, which may not be appropriate for trend analysis, and then deciding on a more appropriate design like showing a line chart. And so in this work, what we're studying is how we can utilize these kinds of multimodal foundation models for visualization design. And the way that we are thinking about this is to approach a multimodal foundation model as a visualization judge, one that takes an input, analyzes it, and then gives us some course of action to then hopefully improve on our design. And so the input, which we could think about as evidence, would be a pair of an image corresponding to a visualization, as well as some user objective that we can supply as text. So for instance, whether there exist trends and cost as a function of time. The model would then analyze the image and text pair, and then ideally give us some kind of action ruling to improve on the visualization. So this is where the specificities of the model really come into play. What is it providing as output? Like a score telling us how good the visualization satisfies the objectives, whether it can give us a new visualization parameter to improve the design, or just an entirely new visualization design. So we believe that this can be addressed through two different kinds of multimodal foundation models. One is a generative model. It may seem a little unusual, whether more off-the-shelf generative model that you would find, for instance, something from like a Hugging Face repository, but it can actually understand visualizations. But here's just one very simple example where you can see by this particular prompt that it can generate plausible, although ultimately not very useful visualizations. And so rather than just treat this as more generative, we think that it's more beneficial to position these models as likelihood-based models. And so the idea would be that given some particular prompt, which is the user's objective, we would like to give a score, a likelihood for any given image of how well that image satisfies the user's prompt. From that score, we can then devise better optimization methods in order to arrive at the optimal visualization. We can also turn towards vision language models, which take in image and text as input, but then provide something much more informative as output, not just a single score, but rather raw text. And so given these types of multimodal foundation models, we can kind of see like this span of this trade-off between design flexibility and optimization flexibility when we're choosing these models. So a model that reports likelihood can be useful and allowing for optimization flexibility. We can perform gradient-based optimization to tune visualization parameters, but this limits us to rather low-level parameters in our design, like color, shape, size, and so on. But we kind of see this as a spectrum. So in some cases, we may have a model that can provide comparative judgments, giving it two different images, and we ask it which one is more appropriate for the task than the other. On the far end, we can have a more expressive visualization critic that can give text as output, but it's very flexible in design, but it's less flexible in optimization. We're limited to what it provides as the output text. So I'll present one example right here in our recent work where we look at this in the context of volume rendering. We're given some visualization parameters. We can produce an image and then ask a model to then judge it. And in particular, this is a model that scores how compatible a text is with the image. This then gives us a gradient-based update in order to create an image of some target objective, in this case, a potted tree. From here, we can then learn a better transfer function for volume rendering in order to arrive at an image that is better compatible with the text. We can also do this in the context of a vision language model, where the model is not just necessarily giving us a likelihood score, but rather a quantitative scalar that we can parse out from its what it provides as output. So I'll end on two main things that I think we need for these kinds of visualization judges in practice. So the first thing we should do is assess how well these models are at performing visualization reasoning. So if we have this simple iris data set and we ask a model to estimate the average value of sepal width for setosa, then it's possible that the model would just simply read off the individual marks and then compute an average from what it's read. This is not necessarily how a human would go about estimating the average value. It's very often they'd use some kind of perceptual proxy like the envelope of the points. So we'd like the way in which a model should reason, we think should be aligned with how a human reasons over visualizations. The other thing that I'll end on is I think that we should be striving towards building a library for differentiable visualization so that we can frame these kinds of optimization problems. Right? So we can be thinking about as our inputs what we're optimizing over our traditional visualization parameters like visual encoding maps and how we compose views. And then what we really need, I think is missing, is a differentiable render. We can take in these parameters in our data set, and then we can have a differentiable function of our image with respect to our visualization parameters. From here, then we can then better frame gradient-based optimization algorithms in order to refine and find optimal visualization parameters here, like an adjustment of view composition. So there's a number of different considerations that we make. I'll stop here due to time, but I encourage everybody to read our paper for more details. So I'm happy to answer any questions. Thanks.
Thanks so much, Matt. Really interesting work. I think we have time for just a quick one. And the one I was hoping to ask you is, based on the user's objective, it seems like so much of the strategy needs to depend on that. And initially I was thinking, oh, that's going to be really hard for people to express. But then you showed a couple of examples that seemed very reasonable to me. And in particular, it seemed like I could see that objective being stated in sort of an iterative way where you're getting feedback in terms of the next state of the visualization. I was wondering, is that how you kind of imagine it, that this is like a iterative conversation about the objective?
Yeah, so I think that's probably the best case scenario. I think what would be less than ideal is in something which is more iterative because there's a language misunderstanding from the model's perspective. So I think that's probably, and I think that's going to be more likely than the other way, where it's a bit more like fluid in terms of the interactions. And so I think that what would probably happen more likely is a domain mismatch in what the user's saying and what the model is understanding.
Cool. Very, very interesting. This also, I don't think we have time to get into it, but I'm fascinated by the differentiable renderer. So if we have a chance to talk more about that in the future. So thank you, Matt. Let's now start moving on to the next talk.
Should I share my screen?
Eugene, that would be great, because you're also beating me to finding my schedule of events. So I'm glad that you knew you were next, and thanks for sharing your screen. Excellent. So let's continue on with our talks here, and Eugene Wu is going to present design-specific transforms in Viz, work together with Remco Chang. Take it away, Eugene.
Oh, awesome. Cool. Well, thank you for the introduction. So I'll just jump right in. So, one of the core theories that underpins data visualizations is Bertrand's data to visual mapping, right? And it basically translates data attributes to visual channels and data rows to marks. And, Wilkinson's grammar of graphics and follow-up work such as ggplot2, VizQL, Vega Lite, and so on, basically expanded upon these ideas to develop grammars to define a rich space of visual design. And today, there's literally dozens of grammars and DSLs for data visualization. And so while they improve tooling and designer productivity, they also obscure the semantics of the visualization generation process. And so let's just look at 4 very common types of charts today. And what we're going to do is they visualize a data set D with 2 attributes, A and B. And we'll just look at a few grammar-based specifications here using Vega Lite as the example grammar. So if we look at the scatter plot, it's specified by choosing a point mark, and then we just map A to X and B to Y. The bar chart uses a bar mark, but we can see that it first aggregates B before mapping to Y. The pie chart specification is very similar to the scatter plot, but it uses an arc, while the proportional stack chart fixes the X position and then maps A to color instead. But the thing is, if we analyze this syntax, it would appear that the scatter plot and the pie charts are nearly identical, whereas the bar chart and the proportional stack charts are very similar. But this also goes against our intuition for what similar means. And so the question is, can we formalize this? Well, one thing we know is that grammars compile to a complex set of data transformations. So let's just separate those out from the visual encodings. The scatter plot in this case doesn't apply any transformations. It just does a direct visual encoding. While the bar chart first groups on A and then computes the sum of B. And it takes those derived attributes colored in red here and maps them to the rectangle's X position and height. The pie chart does a little bit more work, right? It computes the percentage of each group from the total and then stacks these percentages on top of each other. And then these are what's mapped to the arc's color, offset, and angle properties. And finally, we see that proportional stack chart does basically the same thing, but maps to rectangular mark properties instead. And so by examining these transformations, we immediately see that the pie chart and stack charts are nearly identical and only differ in the visual encodings, while the bar chart shares the initial transformations with the pie and the proportional stack charts, and the scatter plot does, again, no transformation. And so this is the intuition that we kind of take to this piece of work, which is we propose to decompose visual mappings into 2 discrete steps. The first are design-specific transformations. Here we denote that as S, that represents all transformations that are needed, right? In theory, this might include even pixel-level binning, anti-aliasing, smoothing, and so on. So that the visual encodings trivially just apply some scale transformations to assign mark properties. To make this concrete, let's say we have a table with 3 rows, and we're going to first count the number of rows in each value of G, right? So we have groups G equals A and G equals B. And then the encodings then map G to the X coordinate, and then C to the bar height. And this is how we end up with a bar chart. In this formulation, the end-to-end process is a sequence of transformations, right? Even encoding is just a special and yet simple transformation. The benefit of this uniform representation of this visual mapping procedure is we can now reason about user tasks. Now, suppose there's a decision the user wants to know, right? A question they want to answer. In theory, this can be answered by composing the right query over the original data set D. But what visual analysis tells us is that the user only has access to visualization and then needs to perceptually and cognitively and mentally evaluate, compose and evaluate a proxy query, Q tilde, that hopefully is similar to Q. And to connect back to other work at BELIV earlier today, this proxy query you can think of as kind of like the strategy and the visualization support steps in Farmer et al. Model in the task and telephones work. Now, if we then look at this diagram and we write out this as a formula, we might first apply the design-specific transformations F to D, and then we compose it with the visual encoding, and this gives us the visual abstraction V. And what the proxy query to tilde is simply another composition of a function, right? And we hope that its result is going to be similar to the base query over D. And so now let's study this equation. Well, one thing we can do is we can then remove kind of like the encoding, right? We can fold it into F because it's just another transformation. And now if we stare at this, what it suggests is that depending on the complexity of the query, right, either the user needs to do the work, right? Or the visualization needs to do work on behalf of the user in order to answer this question. This is what we call the no free lunch conjecture. As a concrete example, consider examining the percentage of A using these three charts. The scatter plot does no work for me, so you as a user needs to sum the points and estimate percentages yourself. The bar chart does a little bit of work by summing the points, but you still need to calculate percentages. Whereas the pie chart exactly calculates this percentage, and so you simply read it from the arc degree. But what if the task or the query changes a little bit to standard deviation of A? Well, the pie chart and the bar chart don't have enough information, so they're invalid. Well, the scatter plot didn't transform the data, and so can answer this. What this suggests is that there's a trade-off between design flexibility and ease of use. So the scatter plot, in some sense, is more flexible in the questions that it can answer, but it's harder to use in general. Whereas on the other extreme, the pie chart is very, very easy to use, but only for a select set of questions. Now, this notion of flexibility also suggests a one way to model tasks, which is that sets of queries, right? Possibly an infinite set if you don't know what the user is interested in. Now, each of these tasks, right, each of these sets of queries then implies different good visual design. To give you a concrete example, let's say the task is the user is interested in, the percentage of some group. We have 3 groups, and so we can simply compute these results and give it to the user. What if we don't know? We don't know kind of like what the user wants to do with these groups. Perhaps they want a sum or a difference sum, but we don't know which exactly and which groups they're interested in. And so we might use the bar chart. But if the task is a little bit more ambiguous, meaning the set of queries is larger, then perhaps we don't know which statistic the user is interested in, and we might use an interaction or a more complex infographic. So this is kind of a, hopefully an interesting way of modeling tasks as sets of queries. Now, this is a BELIV workshop, so let me just remark also on applications of this model to studying design. Now, one thing we can do is now, if you compare 2 different visualization designs, and we guarantee that they only differ by the transformation functions, then you can attribute any end-to-end effects that you measure to the differences in these transforms. And the same is the case if they only differ in the encoding procedure. But what this also says is if you compare 2 designs that vary in both transformation and encoding, then you cannot attribute the effect to either of these steps, right? You don't have enough information. What it also means is that if a design applies aggregation or some other non-invertible transformation, then it's immediately clear from these transformations that any resulting visualization, right, is invalid for some tasks, right? There exist tasks for which the visualization fundamentally cannot answer. And so studying the design efficacy for those types of tasks also doesn't make sense. So hopefully I've gotten you interested in design-specific transformations and how it might help your research and about how you think about visualizations. But I want to end with arguably one of the most important research questions that falls out of this work, right? And I would say that no one in visualization is really thinking about it, but I do believe it impacts our work every day. And that is there free lunch. So with that, thank you very much. I'm happy to take questions.
Hi, fantastic, Eugene. Thanks so much. So I got to start with 2 compliments on your talk. First, super kudos for the connection to the earlier BELIV talk. Very well done. I noticed even getting the diagram in there. And then also, I think, yeah, this free lunch is awesome. Have you copyrighted the no free lunch conjecture? That's like a great thing.
I have to give Remco credit for that
Ah,
one.
nice.
Good
Um,
observation. Yeah,
cool.
copyright.
So I think the question I wanted to pose to you is basically like how far can you take this idea of pushing the transformations to be super, super powerful? And I'm wondering how complex these transformations could be. You mentioned things like pixel level binning, but I'm also thinking of things like in other visualization contexts, like where the data may not be in a tabular form. Like, let's say you had a vector field and your transformation was to compute streamlines. Do you think that kind of thing could fit into this framework?
Yeah, I mean, the way I think about it is, and I'm actually a database person. And so what I've always been interested in is like, what is the line between what visualizations are unique and good at and what databases and queries are good at.
Mm.
And so, the reason why we kind of ended up here is because, transformations themselves are functions, yes, but they're functions under a data model, right? And so the data model we typically play with for statistical graphics is the relational model, the tabular model. But if you switch to a different model, let's say like matrices or vector fields, then there's transformation is well defined in those data models as well. And so the main thing we're advocating here is it's good to separate out what's a computational task that's being performed in order to generate kind of like this visual representation. And then if you can fully describe that, right? And I think you can, even if you're using kind of a different type of data, then you can model what it means to ask a question about the data, right? It's just easier kind of like with databases in SQL because it's so kind of like common and this is what people think about. But I think that a similar philosophy should apply to scientific visualizations.
Very cool. All right, well, thank you very much. We're going to move to our next talk now. Just a reminder, everyone, we've got a lot of talks in this session, and it will help us to hear some of the audience's questions if you can remember to begin typing those while the speaker's still speaking. Otherwise, we can go with my questions, but I think yours are probably better. So please ask those questions early enough that I might have a chance to include some of them. And let's now move to next talk. I'm really excited for this one. I had a chance to look at this paper, and Michael Correll's going to tell us about complexity as design material. Are you ready?
Yep.
Great.
Can you see my slides on the Zoom? Yes. Okay, great. So thank you for the introduction. So this is called Complexity as Design Material. And it is work that came out of a Dogstool seminar where we discussed complexity with some of the folks on this paper, but then also some other folks who weren't able to join us. And the central idea is there's this sort of fight, if you will, in data visualization between sort of minimalists and maximalists, right? So you have like people like Tufte and Stephen Few on one side that really want these kind of very minimal designs for visualization, and then these kind of maximalists on the other side that explore things like infographics and things like that. And we're arguing that this is kind of the wrong way of framing this conflict. And so instead, I would like to maybe introduce a different metaphor for thinking about complexity in data visualization. So if you want to tune me out for the rest of the talk, these are sort of the 4 points that I want to get across, which is that complexity is a tool, and it's a tool you can use or misuse in your design. It's more than just a visual complexity, like we focus a lot on visual complexity in the examples that I showed you, but it's instead built on these interconnected facets. And this last point, right, is we often think of designers, even in the minimalist or maximalist phrasing, as you want to get rid of complexity as soon as possible so you can carry on with the rest of your design work, but we argue that's not the case. So in particular, we're kind of using this framework of complexity is almost like this mixing board, right? Where you can adjust complexity at different stages or different facets, like interpretation or communication, that have interconnected relationships, right? So you might not be able to turn up the volume on one thing without reducing it on another. But to mention why we sort of think this kind of fight between the minimalists and maximalists is sort of misguided, I'm going to ask kind of a silly question, and hopefully you'll see why it's silly. Is color good for data visualization? right? And if you think about that in the same kind of framing, you think, oh, well, color can really be misused, right? There are all these perceptual biases and ways that it's misinterpreted. If you look at it in some designs that use color, they're just totally uninterpretable. And so one thing that might have happened is if you take this perspective, then you could see the viz field divided into colorists and anti-colorists, right? The people who say, oh, you should never use color because it has these biases, it creates all this mess. And then the colorists say, oh, no, it has some utility for things. But of course, this is kind of a stupid question. And it's a stupid question because if you learn about color and data visualization, you learn that it's a thing that it's good for some things, it's not good for other things. You can definitely misuse it, but it has a benefit, right? So maybe the way of thinking about color is to think of it like it's one tool that you have as a designer, right, in your toolkit. And in the particular metaphor that we're going to be using is that color is a design material, right? It's a thing that you can use in your designs, and you can use it poorly. You have to learn how to use it correctly, but it definitely exists, right? So just to revisit that question, I'm now going to say, is color good for data visualization is a stupid question. So is complexity good for data visualization, right? For kind of the same reasons. Like when you're already framing it as this notion of, oh, look at complexity, it can be totally misused, and like all these complex designs are bad, and we should look on reducing it and things like that. But I'd argue this is already framing the question incorrectly. So we're not the first people to sort of have this insight. So at AltViz a few years ago, there was this work by Akbaba et al. Sort of talking about how just even the word chart junk, which is often used to refer to sort of these additional visual elements of designs, is kind of misleading, right? It's this under-theorized word that kind of constrains our thinking space. And so they literally did a performance art technique where they cut the word chart junk out of Viz papers. And we're arguing maybe complexity in general kind of has this problem. So to give some examples of sort of what we mean by complexity as a design material, first I want to think about how complexity exists in the natural world, right? It's not something that's inherently bad or inherently reductive. For instance, this is the cockpit of a jetliner, and it's very, very complex. But there's good reasons for that, right? Like flying a plane is a complex action. You need direct control of lots of orthogonal parts of the process. Right. So if you reduce this cockpit down to something like an iPhone with like a single swipe key, that's not going to work, right? Similarly, there's this metaphor that sort of the author G.K. Chesterton relies called sort of Chesterton's fence. And so the idea is you come across a fence in the wood, and there's a certain kind of reformer person who would say, oh, there's this fence in the middle of nowhere. It's useless. We should get rid of it. And Chesterton's response is, the fact that you don't know why that fence is there is why I'm not going to let you remove it. You have to go back, tell me why there's a fence in the middle of nowhere in the woods. And once you understand that, then I will give you permission to remove it. And we argue complexity the same way. If you don't understand complexity and what it's doing in the design, just taking it out might have negative repercussions. Right. So the last sort of thing we'll mention on this is something called Kessler's law of user experience, or sometimes called waterbed theory, which says that there's a certain amount of irreducible complexity in a design. And just like, when Hercules is fighting the Hydra, if you cut off one head, two heads grow back. In the same way, if you try to reduce complexity, often it just pops up somewhere else in the design. And we'll present some examples of that in the last sort of couple minutes of this talk. Right, so again, we're not going to go too far into these sort of 7 axes of complexity, which is how we structured the main paper. But I do want you to think about non-visual forms of complexity. So the one that we mentioned is sort of this notion of a scatter plot. Right? So here's a scatter plot. We've actually seen this exact data set before, earlier in BELIV. So it's penguin data set. And it has interpretable axes, right? Like bill length and flipper length. These are things that make sense. You can know what it means for instance, a point to be higher on the x-axis than the y-axis. But here's a t-SNE plot of, in this case, the MNIST data set. And visually, I would argue it's the same kind of complexity, right? It's just points with color for class. But now what it actually means to interpret those points is radically different. What does it mean, for instance, for a point to be twice as high on the y-axis in a t-SNE projection? I don't know, right? It's a very complicated, stochastic process, as opposed to this penguin has a beak that's twice as small as the other. Right, so that's the example of interpretive complexity. I'd also argue that visual complexity doesn't necessarily contrast to task complexity, right? So here's an example of a road atlas. It's very, very visually complex. There's all of these symbols being used, but actually using it is not that difficult, right? You go to the section of the map that you're interested in navigating, You're familiar with these symbols because they're roadmaps that you encounter in everyday life. And you're not actually looking at all of this complexity at once. You're finding your own narrow path through those things. So one last example is this interactive complexity. I mentioned the iPhone before. It has 0 buttons in this case, but there's lots of complex affordances that sort of are hidden behind this deceptive notion of simplicity, right? So if you go to see all of the different affordances of data, of an iPhone, right, you can switch apps, you can tap or double tap, all of these things that you wouldn't necessarily discover on your own, right? Pages and pages of affordances of this iPhone, just because you have this one thing. And then the last is sort of how once you get the insights from these phones, from these visualizations, how you actually turn them into action, right? So I would argue that these two flatten the curve graphs, which hopefully people are familiar with from the pandemic, very simple visually, maybe interpreting them is is easy as well, especially with the text devotion. But how you go from this interpretation to, for instance, creating public policy, very difficult, right? Or persuading people about the value of the argument being included in these things. Right. So I will just end the talk with sort of, again, this notion that think of complexity as these things that you intentionally add to a design, right? You have to understand them before you can take them out. Removing them in one part of the data visualization and sense-making process often makes it pop up somewhere else. Right. And so in general, right, it's a tool that you can use or misuse, right? It's not necessarily intrinsically good or bad. It's a thing that you use. You have to learn how to use it correctly. And this focus on the visual sort of elides all the other places where complexity pops up in the design. So with that, I will stop and take questions.
Wonderful. Thank you, Michael. We're getting a couple of questions coming through now on Slido, so I'll ask you to go there when you're done. But let's just take the first one for a quick answer. I think you were starting to get to this maybe as you were putting up also your different axes of complexity, but it's just can you elaborate a bit more on how you would formalize or define complexity in this context?
Oh, I wouldn't. That's how I would do it.
Aha!
Right. Complexity is just such an intrinsic, we discussed this in the paper, but essentially complexity has so many meanings in every other field. And a lot of these meanings don't interoperate. So maybe like one of the things that we work on is just complexity is a thing that makes things harder. If you take that definition, that's one way of doing it. There's another definition that we like from Don Norman, who wrote sort of Living with Complexity, where he distinguishes complexity, which is a property of like a system, like a UX system, and complicated, which is a property of the world at large, right? So flying a plane is complicated, but the interface for flying a plane could be complex or not complex. So those are two different, one formalization is essentially throwing our hands up and saying, it's this concept that nobody really seems to understand, but all seems to have impacts on our designs. And the other would be to talk about sort of complexity is a thing that lives in the head and complicated is a thing that lives in the world.
Great. Very nice. And actually you probably didn't see Slido yet, but you're beginning to answer question number 2 already. So well done. Although I like your first answer best, which is we don't define it. Mic drop, I'm out. That also works. Very good. Thanks so much, Michael. We're going to move to the next talk now. Jasmine, if you'd like to start sharing your slides, that would be great.
Quick mic check.
Yep, I'm hearing you just fine.
Excellent. I'll start sharing my slides now. I'm very glad I'm going after Michael's talk because I'm about to address the question of how are we going to find that complexity? How are we going to use actually this design study method to identify when we have satisfied the requirements of that complexity? And I'll clean up that notion as we go.
Great. Welcome.
So let's start with some examples of paper mark making devices on paper. You've got your blackboards. You can always ask an expert to write their model for you on the blackboard. You'll get an interesting domain-specific representation. I want to keep throwing repository types at this. This is before we get to the data set, before we solicit that, we're going to think about other ways that your experts are actually visually representing their information. And it's not just how they're sharing it with you, it's how they share it with each other. They might go a bit harder on the jargon. They might play a complicated war game, something like that. Or they might write the jargon on little cards and move them around. And what's interesting is that we have this theoretical lens of the boundary object that lets us roll up all of these ideas into one shared notion of this is something that facilitates communication, collaboration. And I want to figure out why this is so powerful for visualization. So this talk is in 3 parts. We're going to start with what does that collaboration mean? So restating, we often have the problem where we deliver the system and it's like the expert comes back to me and says, I already knew that. Yeah, I already knew that would be in there, but it's nice that you visually confirmed it. And that actually is wonderful. That's perfect because now they're a very powerful expositor of that information. What's more is that my visualization does in fact help them the moment they need to go to anyone else who isn't able to stare at this notation and derive that same insight that obviously they've spent months and years obtaining for themselves. So we are helping, but not in the way we thought we were. Let's be more specific. So this is Tom Gauld's wonderful cartoon about why names are really misleading. And sometimes when you look at, here we have a very simple world where there are 2 ships and 2 huts and 2 towers and 2 castles. But if we did those interviews and we never solicited any boundary objects, we would receive 2 completely different stories about how orange has this awful process and purple has this wonderful process that have nothing to do with each other. So we would really love to be able to achieve what we're calling in this paper a horizontal transfer of knowledge between the orange and the purple domains. And I realize this is a very short talk slot. We'd love to expand this idea. So we have the horizontal transfer. We also have vertical transfer, which is just your standard. Experts go up and down their domain of expertise very readily. Let me give you some examples with the case study we ran that this work emerged from, where we actually had what we're characterizing as 4 different verticals of stakeholders. And along that HCI vertical, that's a nice clean vertical because we're able to perfectly apply the Munzner's nested 4-level design study method. Everybody on here understands what we're going for as we're soliciting their tasks and producing the prototypes. Now, everybody else on here doesn't really care. But the beauty of the visualization is that even when you don't have full buy-in on the process, you can say, oh, well, let me give you this report, and we used this tool to make it, and we wouldn't have this nice report if we hadn't had the resources to make that tool for you. Restating what I said. So that's the first part of the talk. Let's go into the second part. So what do I mean by knowledge production here? Again, here's an example of, it's not actually the same, of a tabular representation of a CSV data set versus a schedule representation. When you add information about the sorts and their relationships, you get beautiful predicate structures, whatever, that you use to build up a complex encoding. And that's going to be, even though it doesn't do those low-level tasks as successfully as the spreadsheet, you're able to compact those rows into a way that you can start to see gestalt effects. Very useful. We have lovely design principles from another data to discovery team that actually, I won't go through each of these, but they're telling you, okay, this is how we think about making this design happen. This is how we reflect on the system, the visualization system we've actually built on the basis of the data that we're taking in. We're going to pop a level up. We're going to go up 1 level of abstraction and think about this fuzzy cognitive mapping tool. There are many like this. Loopy is a very good one. this is more at the brainstorming level of we don't have data yet, but we need to solicit the systems model that our stakeholders have in their head as a boundary object. So you might do this earlier, and we're claiming that forms another reflective loop. And for a while that can run on its own, but what you really, really want is to take these two loops, this high-level reflection and this low-level reflection, and just kind of smash them together. And that's how you're going to get those boundary objects to actually circulate between levels of your organization and transfer knowledge all the way up and down. So I think I will click through. I'll show you when we code up the nested model this way, we have some boundary objects circulating. Boop, we added 2 more levels. There's no more monad complexity. It's just a nice 4-level model that we can, now we have the vertical moves. We've reintroduced that notation from the knowledge transit graph. And for want of time, I'm just going to click through section 3 very quickly. Wicked problems are explained in the paper. They're from urban planning. And we're going to have that data coming in once into your visualization process. We're going to produce some prototypes that are going to be direct representations of that data. People are going to look at those representations and they're going to go, no, that's not what I meant. Oh, it's over there. Oh, I didn't even realize. And then finally, they're going to take that and go back to their stakeholders and say, hey, so our area of concern is actually over here, it turns out. And there are a couple of historical references I would love to bring in here from other national labs, but let's save it for the conversations after. Thank you. And I am on the job market this year.
Great. Thank you so much, Jasmine. Very interesting. I hadn't heard of this topic of, I hadn't heard the phrasing boundary objects before. So this was really a nice conception for me to think about. Thank you so much. I think what I'm going to do is actually move right along to our next talk and keep things moving so that we don't fry everybody out. We're just a couple minutes behind schedule. So Jasmine, could you take a close look at Slido and Discord in case there are questions there? I think that would be great. Let's see. So the next one that we're going to move to is a talk by Lonnie Besançon, and I am going to share that with you.
Hello everyone, happy to see you here online, unfortunately for the merits and limits of pre-registration for this research. My name is Lonnie and I'm presenting this on behalf of my co-authors that you can see here. I want to first highlight that this paper stems from many discussions that we had between us co-authors, but also discussions within the whole scientific community across different domains. First things first, what is pre-registration? Pre-registration is the process of recording, if you think of the research pipeline like this, the data collection and analysis before you actually start doing it. The goal of this is to allow reviewers to then compare the recording that we said we would do versus the actual paper that we submitted when they get to peer review our manuscript. In practice, it looks like a document that you can see here on the right with a timestamp given and then with different sections that then correspond to the paper on, for instance, participant recruitment and data analysis, and the reviewers can compare these to validate that we did do what we said we would do. The idea behind this paper stems from an IEEE Viz 2022 panel that we co-organized with Mohammed and Cody, and for which we invited Brian, Tamarinda, and Mariah to talk. From this panel stems 3 different things that I want to highlight here. The first thing is that pre-registration is a plan and not a prison. What I mean by that is that deviations from your plan are allowed. remember this graph when I said that actually if reviewers compare, they need to manually check that you did do what you said you wanted to do. Sometimes there will be mismatches, and that's actually fine. If you actually did what you said you would do, then you just report it as is in a paper, right? But if you couldn't, then you can transparently report in a paper that you initially planned to do X, Y, or Z according to the pre-registration, but because of a specific reason, you couldn't. And instead you used another method that gives you another set of findings. So the only thing that this forces you to do is to be transparent about what you have done, and this won't prevent your paper from being published at all. In fact, looking back at my papers, I have deviated from my pre-registrations quite often, and all these papers have been published, so it's really not an issue there. A common misunderstanding is that pre-registration is only for quantitative analysis, and this stems probably from the fact that we use it a lot for clinical trials. But it can also be used for other kinds of research. For instance, Tamarinde here co-authored a paper on the pre-registration of qualitative research and giving some templates and advice and benefits of doing so. Looking at our own paper here, we actually have pre-registered it. There's a specific part of the paper that is a LLM-based summary of the panel that was done through ChatGPT and pre-registered. So we report on it in a paper, the pre-registration is available online, and we also report on the deviations we have and the actual summary per speaker as we wanted to do initially. But thinking of the different kind of flavors of research that we have in Viz, if you think of system and software papers, for instance, what could be pre-registered, is the performance variables that we want to focus on or the data sets that we plan to test this on. For the review or survey papers, we could easily pre-register the inclusion or exclusion criteria, the queries to find papers, the appraisal criteria, or the potential use of standards like Prisma. For user studies, I'm not going to dive into this. There's many papers on this. But for theoretical paper, there's not a lot of research done on how pre-registration could be useful there. But we think, we co-authors, that it could be used maybe to record our prior assumptions or our motivations. The last thing about pre-registration is that it's all about epistemologies, right? When we think of research, when most people think of research, they think of hypothesis-driven research, right? Which is positivist research. But there's many other epistemologies, especially in Viz research. But for hypothesis-driven research, it is fairly obvious that there's a close tie between replicability, reproducibility, and pre-registration. But for non-hypothesis-driven research, perhaps pre-registration could be adapted to help us record positionality statements or pre-reflections or reflections across processes, even to serve as maybe something like an open laboratory notebook to retrace all the steps of the research that we have done. And this is something that the Viz community is already thinking about if you think of analytical provenance, that is one of the topics of research that we have, as exemplified by this paper. Or if you think perhaps of this design study from Rogers et al., in which the authors actually designed a whole website to link every finding or decision they have in their paper back to some specific artifact of their research process. The problem is that such website was made as a companion website and was not really directly available through the paper because we only submit PDFs, right? But that's maybe something that Jovi, a newly started journal with, for instance, Matt Kay here in the audience, can help with, because we allow people to submit interactive web-based papers through GitHub, for instance. So yes, it is all about epistemologies, and maybe pre-registration as we see it today is not really adapted to all the flavors and epistemologies of research that we have in the Viz community, but maybe it could be adapted to actually be helpful in those cases too. In the paper, we also give some practical advice on how to pre-register the platforms and their benefits, but I'm not going to dive into this here. So I want to summarize this whole paper by saying that pre-registration is very tightly linked to replications and replicability, of course, but it does not equate replicability at all. Pre-registration is but a tool to help us transparently report on our processes and decisions and results, right? Among many other tools, right? There's many others that people can use and maybe should use in some cases. But yeah, pre-registration does not equate good research at all. And, you know, it's not going to replace good and good thinking and strategic discussions and iterations over your designs at all. It's just a tool to help people report and think about some of the things that they're doing. And I would know quite well about this, and this is a bit of a shameless plug, because if you see here the headlines of a science article about some of my findings on bad papers, I can tell you that some of the studies that I reported on are sometimes pre-registered, and that doesn't prevent them from being bad. I invite you to come to my poster presentation on Tuesday about this, so that we can talk about this more if you're interested. So to conclude, pre-registration is a tool that we can use and that maybe the Viz community should work on to adapt to all the flavors of Viz research that exists so that we have something that is useful for everyone. And maybe it will change name actually. Maybe it will not be exactly a pre-registration, but a pre-reflection. Or maybe it's going to be something completely different even. But the idea behind this is we want to increase the transparency of our processes so that they can be reused among the community by other researchers. So I think we're the best researchers to do this work because we deal also with human-computer interaction, and the transparency of research processes is a human-computer interaction problem. I invite you all to actually come to our OSF repository where there's a Google Doc for you to put some thoughts and start some discussions if you want. I thank you very much for your attention, and I'm happy to take your questions.
Hi, Dan.
Hi, thank you,
Can you hear
Lonnie. I'm unable to start my video because the host has blocked it and I thought I was the host. There we go. I'm back. Thank you. Really interesting work, Lonnie. I'm going to ask if you don't mind to do the same thing. Let's keep it moving because we got 7 papers here and I want people to be sure to have a break so we can have good breakout discussions later too. So do you mind taking questions over to Discord? We have
I'll take that.
there, and I see actually you already magically while you were speaking responded to one of mine. So thank you very much.
I'll continue doing that. Thanks a lot.
Excellent. All right, and our last speaker is Tobias, and are you ready to share already? Excellent. So great. We're going to hear now about state of reproducibility stamps, and please take it away as soon as you're ready.
Yes, so sorry. Now that we heard something about things that happened before you actually start the research on a paper, or at the beginning of the research of a paper, I want to talk about something that happens after, which is a certification that your work or your results are reproducible. And the motivation for that is, of course, that in most of science, if we have some results, we can really only believe it once somebody else verified what we found. And in our field, of course, we need code and data, and that's luckily happening a lot already. We have GitHub repositories, we have GitLab, we have OSF, so that's happening a lot. We see a lot of links in papers. However, just having code and data is usually not enough. Questions are, is it well documented? Does it actually run? Does it run reliably? Does it produce the promised results? People in the graphics community, O'Neill et al. Here at 2020, actually checked that for SIGGRAPH for a couple of years and found that even though code is quite prevalent, getting it to run is a whole lot of work. And partially out of that work also came this initiative that's called the Graphics Replicability Stamp Initiative that actually helps us check this. We can actually apply with our results, with our repositories to get somebody independent to check this. But before I talk that, I want to quickly mention terminology. So when this whole discussion came up, people initially defined reproducibility as a different team using the same setup as the initial group to check what's going on. And replicability, that same different team, but with a different setup. So essentially for us, that would mean to re-implement everything. But then ACM came along and switched the terminology. So they talked about replicability for the same setup, different team, and reproducibility, different setup, different team. Until 2020, when they realized the problem, I suppose, and switched back and used the same terminology as was used in the beginning. And that's also what I'm going to do in this talk. So for me, reproducibility is same setup, different team, whereas replicability is different setup, different team. So what I wanted to figure out is, well, how are we doing? How are we doing this in visualization? And so I started with this initiative, Graphics Replicability Stamp Initiative, and there you see this terminology problem because it was founded before ACM switched over. And I looked at the website, and luckily they not only have graphics papers there, but there's also visualization papers. So I took this information, scraped the website, put this in a database, also looked up the papers on the digital libraries. We Explore and Elsevier have APIs. ACM and Wiley do not. ACM, you can do something with some tool to look it up, but usually you can look up this information also on Crossref for ACM and Wiley, even though this information there is not complete. But I also looked at our own data. WISPUB data collects visualization publications, of course, other visualization venues. I can look up at other resources like Eurographics Digital Library or Computers and Graphics. And there's a couple other little databases or data sources that I also looked at. So what is the data like? So here we see the spread of the certified papers split by journal. We see that TVCG has the highest number of certified papers, closely followed by TOG. Elsevier Computers and Graphics is third, and then come Computer Graphics Forum and some other journals. They recently actually added also the SIGGRAPH conference papers as a venue. So even though when I talk about journal, this is now also included. The data, by the way, is current as of today or this morning. We can spread this out over the years. We see that initially graphics venues were very active. TOG was the leading venue initially, but then TVCG caught up and currently has the highest contributions, but also Elsevier's Computers and Graphics is increasing quite a lot recently. So then, of course, this is not about just graphics or the whole data set. We want to know about visualization. So what is visualization? And here, naturally, we don't want to bias this analysis. So we try to look at as much as possible classifications by the authors themselves. So we basically look at what was published at Viz, Euroviz, Pacific Viz, or presented at these conferences as journal papers. And then there's a couple smaller conferences that also have special issues in particular Computers and Graphics, so VCBM, MolVA, EuroVA, and UnRevis I pulled out of Computers and Graphics. And then there's a couple other papers that are not part of these classifications that I classified either by keywords or with a manual decision where I thought this is really visualization. All of that is documented in the paper in the appendix. And with that, you can see that visualization started about 2020, or papers in 2020 started to pick up. There's a drop in 2023. That's because TVCG in that year didn't really follow in giving early publication to those papers that were certified, which they otherwise promised, but they fixed that in 2024. So that's why 2024 is already higher. And then we also have the in-press papers. Where do Viz papers come from? They come primarily from TVCG. And here we see the separation into papers that are classified by presentations at conferences, essentially, versus with the lighter colors, those that are classified manually or by keyword. So we see that TVCG is by far the biggest journal where we have visualization papers that are certified. And all the rest is really a small contribution. We again can split this over the years. And this is, by the way, the years when the papers were published, not when they were the certification was requested. We see that things pick up in 2020, and we see the spread over these years. Now we can also ask, well, what about our different venues? Because we have this information. So here's this data about the different venues. This is now not published, but presented years. And we see that initially not a lot of certification is happening, but in 21 we see things picking up. And if we can see that better if we look at this actually percentages. By percentages, we see that these days we are in the 10s to 20%, sometimes spiking a little bit higher than that, but still fairly low numbers. Of course, we also can ask, how about authors? And if you look at the authors, overall, we see very much a power law distribution, which is to be expected. Many authors only have a single certified paper in the database. And then a few, as you go with to higher numbers of certifications, lower and lower numbers of authors. And the same is true if you look at the visualization only authors. And those are, in my classification, those authors that have 50% or more visualization papers. We can also ask, well, how's the split between Viz and not Viz? And we see this is a pretty bimodal split. Now, because that also includes authors with a single paper, which by definition can only be either Viz or not Viz. So if I take that out, then we're still left at a bimodal distribution. And this middle point where we have 50-50, authors with 50-50 papers, is still an order of magnitude lower than, let's say, the no Viz authors. And finally, we can ask, well, in which countries are these people working who get their papers certified? This is, again, all GRSI awarded papers. Biggest contributor is the United States, followed by France, China, and Germany. And then the contributions drop off fairly quickly. And there's lots of other countries that have less than 2.5% in this example here. If you look at Viz-only authors, the order switches slightly. Again, US is first, France is second, but then Germany is third, and China is fourth. And some other countries follow suit. Now, what does this mean? Well, numbers are still low, but they're increasing. If we look at the overall GSI, we have less than 30% of papers that are from Viz, but if we look at the recent years, things are improving. If you look at the presentations at conferences here only for Viz, the numbers are very low. So for Viz between 21 and 24, 4.3% have a stamp. And if you look at the TVCG presentations at Viz, close to 20% have a stamp. And the difference, of course, is because TVCG offers this early publication for awarded papers. So why are these numbers low? One possible reason is that the GRSI is not well enough known among authors. So that essentially means that we need to advertise better. So I mean, this is mentioned repeatedly in like these editorials in the journals. Here's an example from TVCG. But maybe this is not read enough. So we hopefully can advertise that more at the beginning, opening sessions of our conferences. This is, by the way, also advertised in the acceptance emails that you get for papers. But still, maybe people don't read through all of that. But as I said, things are improving. And here's the numbers for proper Viz papers over the years. And this year, for this year's conference, we already have 7 papers certified, which is more than by now have been certified from last year, and it's the same number as have been certified from 2 years ago. So that's great. Then we can say, you know, maybe there's a lack of incentive, and this is extra work, and maybe it's the perception is it's only eternal fame and glory. So maybe you can offer other incentives, possibly awards. For example, Computers and Graphics offers an award specifically for certified papers. But I would also argue that the GRSI certification helps you as an author too, and I will give you an example in a little bit. Another reason that could be a reason for these low numbers is that the Viz papers or Viz as a venue is underrepresented in the possible GRSI venues. So as we saw, primarily our papers come from TVCG as more or less the only journal with Computer Graphics Forum and Computers and Graphics really have low numbers. So possibly we can change that. And I would like to talk about this. There will be a meetup later this week on Thursday, right after the last session on Zoom. If you're interested, send me an email and I'll let you know about the Zoom link. Finally, or not finally, fourth reason could be that some work is inherently reproduced because it, for example, requires special hardware. And here maybe we could address this by having an inventory of the different GRSI reviewers, what kind of hardware they have access to. So some standardized hardware like for VR, AR headsets could be recorded so that those kind of papers are then assigned to those kinds of reviewers. And a final reason that I can think of that prevents certification is that if you, as an author, have commercialization intents, if you have proprietary code, that certainly prevents things. And there I really don't have any idea how to solve that problem. Nonetheless, I said that it can help you too. And this came out of writing this paper because, as I said, I looked at the website, scraped the data, and then, of course, I come back the next day and the data has changed. And now I'm a lazy person. So, of course, the whole thing is scripted, which is great because then you can basically produce the graphs that are the analysis here automatically. And it also allows you to fix errors that you may notice in the process. And I did find a couple of errors along the way. But the cool thing that came out of this approach is also that not only are the visuals produced, but also in the paper I want to discuss numbers, right? And I don't want to go into the paper and fix these numbers every time. But with a script, you can, of course, also write out some tech code, some macros that give you these numbers so that in the LaTeX paper itself, you basically just use the macros and the numbers are automatically updated. So that's great. And by the way, that the problem with that may be that you cannot use numbers, but the Romans solved that problem, luckily for us. So with Roman numbers, you can solve that problem easily. So to wrap up, the paper is available. There's a GitHub repository to fully reproduce, run the Python code, then run LaTeX. And that gives you the data as from publication time. And if you want to get updated data, there's documentation on GitHub. Go to the link. Thanks to various people. And again, if you are interested in this topic, let's meet and discuss this on Thursday. Thanks.
Fantastic. Thanks so much, Tobias. I love how you say I'm a lazy person and then carry on to show us all the Python code and LaTeX macros. Perfect. Okay, so we're just a few minutes over our session time, and I'm going to suggest the same thing. Let's bring some discussion about this paper to Discord because this is supposed to be your lunchtime. Of course, who knows what it is wherever you are, but we have a break now for about 25-ish minutes. And so we'll see you all again at the next session. After that, take a break, get some lunch or something, and see you soon. Thanks so much again to all of our authors, and please do continue the discussion online. Thanks, everyone.
Great. Hello, everyone. I'd like to welcome you all back from your coffee break or lunch break, depending on your timeline. For this last session of papers, we have 4 papers that are just really interesting that sort of cover a range of topics around the strength and reliability of our methods, including looking at some across different paper types, different contribution types, different technologies. So I'd like everyone to give our speakers a warm welcome. As always, we'll be looking for Slido for questions, so please put them in there. Although, given the stream delay, we will also be looking at Discord. So if your questions don't show up in time, please check there as well. So with no further ado, Shada, if you want to start sharing your screen, we'll move on to you first. So our first paper is called Testing the Tests, Observations when Assessing Visualization Literacy of Domain Experts, which is sort of really interesting look at a very commonly used instrument that I've been seeing more and more in data visualization, the VLAT test for visualization literacy. So with that, take it away, Shada.
Thank you. Yeah, I'm Shada. I'm a PhD student at the Visualization Research Center at the University of Stuttgart. And I will present your paper that addresses the issues that arise in the assessment of visualization literacy of domain experts and gives possible suggestions for improvement. The motivation behind our paper comes from that we work on projects with interdisciplinary collaboration, especially with architects and social scientists. And when we conduct studies with domain experts, it's important for us to assess their visualization literacy. So this can be relevant later in the development and evaluation process. And one method to measure this is the use of standardized instruments. One of them is the mini-VLAT test. which is known for its short and effective format. It consists of 12 questions and 12 different chart types. And as you can see here, these are the different chart types that are given. And important is here that you have also a time limit of 25 seconds per question to answer. And in a previous user study with domain experts, we included the mini-VLAT. However, we made some unexpected observations, like that the given time limit introduced some time pressure on the participants and caused stress on the participants, and it made them skeptical about the test. And since we don't think that it's appropriate to put domain experts under unnecessary stress, we investigated this further in an extended study, and this is also the focus of our paper. And in this extended study, we first let them complete the mini-VLAT test. And in the second step, we did an interview with them. We asked them about their feelings, the issues they encountered, and about possible solutions they would suggest. And in the third part, we proposed some design ideas to modify the mini-VLAT and asked them to rate these suggestions. Our participants were domain experts from the computer science, the social science, architecture, and engineering. And I will now present the most important points made by the participants about the test. The time is an influencing factor in the test. All of our participants reported that the 25-second time limit was too short to them. For some, the time pressure was so stressful that they lost the focus and couldn't answer some questions. And you can also see here that they rated the temporal demand the highest. And surprisingly, there was also a group of participants that managed to stress better than the others. They reported that the time pressure helped them to focus on the task. And additionally, there were also 2 participants who felt that the time limit had some kind of gamification effect on the test. Time to discuss.
Say that you're currently muted.
Okay, can you hear me now?
Yes.
Okay,
Yes.
sorry. Yeah, so in the interview, we also spent a lot of time discussing the questions. The participants noticed some ambiguities in both the questions and the visualization.
Say that one more thing. You have to share your screen again.
Oh, okay, sorry. Then I'm sorry for that. Okay, let's try it again. Okay, can you see my screen now?
Yep, you're back. Thank you.
Okay, sorry for that. Yeah, so in the interview, we also spent a lot of time discussing about the questions, and the participants noticed some ambiguities in both the questions and the visualizations. Like here, sorry, here. The order of the legend here didn't match with the order of the attributes here in the stacked bar chart. This confused most of the participants. And it was also noted that the questions had varying levels of complexity, which would require different amounts of time to answer. And many participants noted that some questions were aimed at the US audience because you would need a general knowledge of the US stations locations, like here, when they had to find where Wisconsin and New York was, and this was a bit challenging for the participants to find this within the 25-second time limit. And last, reading the values within a visualization was also difficult. Several attributes had very similar values, like here, and they had to find out the smallest value for gold. Yeah, you can find further important aspects also in our paper, like about the test purpose, the target domains, and the self-assessment. And in the final part of the interview, we present suggestions to adapt the test to provide a more understandable and comfortable test experience. And our design ideas were to remove the time limit completely to avoid some stress, then to provide meaningful context to the question to improve the understanding of the question, the visualization, to make the context more narrative to provide a more engaging experience, then to adapt the question to domains they are more familiar with, like asking an architect questions about buildings or different materials. And the last idea would allow participants to criticize the visualization in order to be able also comment on misleading visualizations. And each of these design ideas against the mini-VLAT. And you can see that most of them prefer the new design ideas over the original one. If you
Seda, I'm
We
sorry,
lost
but
you again, so you
yeah.
you came in muted and you'll need to reshare again. Sorry.
Okay, I'm sorry for that.
You're back.
Do you see the screen now?
Yes, you're perfect.
Can you see my screen?
Yes.
Can you see my screen now?
Yes.
Yes.
Okay, I will try it again. Yeah, so they argued that removing the time limit would also remove the challenge, or adding context to questions would also cause that the cognitive load would be higher because you would have more text. Similarly, the same for the narrative way. They would need more steps to understand the task. But mostly they were positive regarding these ideas. And for the domain adaptations, they also said it would make the questions more familiar and relatable. Yeah, these were the most important points from our evaluation. Then I would sum up the key insights from our study. If you want to use the mini-VLAT in your studies, you should be aware that the mini-VLAT needs to be revised. The time limit is too strict, so the resulting pressure has significant consequences. You should either give them more time or you should rethink of whether a time limit is really necessary. Then there were some ambiguous questions and visualizations, so these need to be revised. Adding context to the questions could be done, but there's also further research needed to investigate the impact on the perception. And the questions with unfamiliar demographic references should also be adapted appropriately. And the test likes also advanced visualization techniques that are common in visual analytics tools. These could be also added. Yeah. It is also critical to create a stress-free, comfortable environment if you work with the domain experts. And the question should be also designed so experts can read and respond to them in a meaningful way. And the last question would be, is the test really the right format for assessment if you do it for the domain experts? That's all from my side. Thank you.
All right. Thank you, Shada. So we have a few questions coming in on Slido, so I would urge you to look at them. I'll lead off with sort of a combination since we're a little low on time, which is to what extent, one of the benefits of the mini VLAT is that it is sort of, a standardized comparison between these two things. But, as you found, there's seems like there might need to be adjustment to different users, different audiences, different scenarios. So in that case, is something like the test even fit for purpose, or do we think we should look at more specific tools for evaluation? In other words, can we save the mini flat by doing these adaptations, or do we maybe need to look elsewhere for new tools to use?
Sorry, can you repeat the last sentence?
Right, yes, it's sort of, can we save the mini flat, right? If we perform these adaptations, does it now again function as a tool that can be interpreted across audiences? Or if we start creating individualized tests for different audiences, we lose that ability to compare. In other words, is the framework of the test worth saving, or do we need different tools for evaluation?
Oh yeah. So we also thought about if a domain adapted test maybe could be the right solution, but it could be also its drawbacks. There's a trade-off. So yeah, it would be directly adapted for this domain experts, but on the other side, it wouldn't be general, so you cannot use it for other domains. And this means that it must be worthwhile to use this. So this is an open question that we also said to us. But I guess there is no real answer for this.
Yeah, the result of the mini flat making people in Baden-Württemberg find out where Wisconsin was just seemed like a sign that maybe someone should have thought through these questions in more detail.
Yeah.
But yes, there's at least 2 or 3 more questions, but maybe if we can move on to the next speaker. So you'll need to unshare your slides, and then Anna, if you'd like to share your screen.
Okay.
But thank you.
Thanks.
Just, I think you need to hit.
To stop sharing.
So sorry, but I can't find the icon to stop the sharing.
There we go. All right, so this next paper comes from Anna Cresson, who's now at the University of Waterloo. And it's one of those papers where you're making like little fist bump gestures like halfway through. Like it's a very, very strongly opinionated paper that, with a little like righteous anger shot through it. So I highly recommend going through it after the talk. But
Thanks,
since
Michael.
we're low on time, I will just let you get started.
It's a really solid compliment. So thank you. Yeah, I'm going to talk about how we don't know how to assess LLM contributions in Viz/HCI. It's a position paper. I wasn't originally going to write this. I actually wrote it the day before BELIV, and I was telling somebody before the deadline, oh, I've got like it in my mind to like write this kind of paper, but I don't know if anybody would read it. And this person was like, I'd read it. I was like, okay, well, I'll try and we'll see what happens. So that was how this came to be. And so part of the reason why I wrote this paper was actually volunteered to serve on 4 program committees. And there were a lot of reasons for that, but one of them was just this genuine curiosity about how new technology is appraised. I think that just as I say this, there is some sort of ethical quandary about using this kind of an experience as research because you want to make sure that people receive good reviews on their papers. So I've served on program committees for a really long time, have submitted papers to these venues, both successfully and unsuccessfully. And so I actually felt that beyond my own curiosity, that my contributions as a reviewer were actually merited and strong. And there were also some other reasons why I agreed to do this. So, it's a lot. And what I saw was kind of like perhaps concerning and allowed me to reflect a lot on the review process, how we evaluate new work and how we evaluate new technology. And this was because I think like of all of the papers that I was reviewing this year, and I'm sure that many people that reviewed for Viz, that are currently reviewing for Chi, and that have reviewed really at any other venues over the past like 2 years, have started to see the proliferation of papers that are featuring, large language models specifically. And I think well over 60% of the papers that I reviewed had some sort of large language model content. And I think that could be possibly because of what I'm interested in and what I study, but also just, as I said, the general proliferation of this topic. Now, we've seen through conference proceedings, the large language models papers that sort of make it through. And in this sort of work, what I wanted to reflect on was what about the papers that don't make it? And also just some common themes and issues that I saw, which, while I don't have an answer for, I think was an interesting point of discussion for our community. So in my position paper, both as sort of like usually serving a role as either the primary or the secondary or the 1AC, 2AC, I saw a lot of common and recurring critiques. I obviously cannot actually tell you word for word what I saw. That is a significant ethical breach. And so these are really aggregated at the high level. These are really reflected on sort of my subjective interpretation of what I saw. And there's 7 of them, and I've kind of chunked them into some lessons that I took away from them, or like some details about what those critiques were. And then also some of my own subjective opinion of, when I thought some of those critiques were valid, and some of the concerns that I have with those critiques as well in terms of their fairness towards the authors. So perhaps one of the most common critiques that comes up is that large language models have non-deterministic behavior. And so one way to think about this is if you take the same prompt, the same query, or whatever, you give it to a language model, the same language model, you do it multiple times, you will get a different response. I have seen this personally as well. I'm curious about how language models write code. And literally the same prompt, sometimes I'll get executable code and sometimes I won't. And I haven't really changed anything except the time that I'm executing it. This is some like low-hanging fruit, but it is something that comes up as a critique of sort of dismissing language model work in general. The other one is that you didn't evaluate against enough language models. I think it's pretty common for people to evaluate against ChatGPT. I think OpenAI has done a really nice job of making a simple API interface for it that everybody can use. You just sort of integrate it nicely into your tools. But it is the case that there's a lot more than ChatGPT out there, that different language models will also provide a different response to the same prompt. All right, so you're starting to get a sense of like the actual response space is quite variable and larger than we appreciate. And then, of course, there's developments that are constantly occurring. And so there's also the critique that you just didn't evaluate against the latest large language model. I saw this particularly at Chi last year, like GPT-4 was released in July, and there were critiques already in that reviewer cycle of like, but you didn't compare against GPT-4. And I have this tweet I saw from Juho Kim, where he actually talked about how he evaluated, or they incorporated the latest OpenAI model released on the day of the Chi submission deadline in their paper. And so like that's not to criticize their practice. It's just obviously that like not everybody can do that. And this is concerning. So new LLMs are constantly emerging and they have substantive performance gains. So when we take this first 3 batches of critiques, what it kind of comes down to is people are saying, you're reporting this performance, you're trying to study this behavior, but you just got lucky and you're not actually showing the full range of performance or what things might look like out in the wild. And while it can be a valid critique, I don't think that we should dismiss it. I think there are also concerns that I have in terms of asking the authors in order to mitigate that, which is it's actually expensive to run these things, especially if you go towards more of the open source models where you have to host them yourselves sometimes in order to run them. It starts to get pricey. There's unequal access to large language models, especially the latest models. Some labs do have proprietary access and privileges and the finances to run them. This is true for any kind of research that we are doing. And it's not to diminish those labs, it just might actually exacerbate inequities. So only certain people can actually address these 3 critiques. The next batch of critiques is actually not just about the language models, but the acceleration of the research on language models that's coming out. And so a lot of critiques are like, hey, this paper is on arXiv and you didn't talk about it and it obviates your results. That sucks. It might come out a week or 2 before you're about to submit. Another one, and this one I actually saw a lot, was that you didn't cite any relevant research, and I don't have a ton of sympathy for this. We saw a ton of papers. I saw a ton of papers in like my AC stack that was super surprising to me, that were submitted to like Chi or Viz, but did not engage with any of our prior work or literature. So this is an example of folks from other fields, citing a lot of NLP and ML work, and just basically like, hello, I'm submitting my paper now to Chi and Viz, which exacerbates our reviewer workload. So there were like 2,000 more papers to Chi this year, which is crazy. And some of those works really do not engage with existing literature in our fields. There's also like the summary critique called the LLM wrapper paper, which is basically you've built an application and just sort of slotted in a language model in the back end. And so you kind of get a publication for free because of these language model capabilities. And that's also been a concern of some folks as well. So this sort of batch of reviews that kind of came out is like your quote unquote novel research is actually just like low hanging fruit of LLM capabilities. And a lot of it has to do with timing. And when you combine it with the other part, it's like, you got lucky overall, is what the concerns are coming from the reviewers. But here too, there are also, I think, some critiques where it's sort of challenging for authors to really manage this. So one is that there's archive papers coming out constantly, and there's a ton of these papers that are flag planting. So even if there's prior research in your area, like doing the same thing you're doing, it doesn't actually mean it's good, right? And that's a problem. You shouldn't be necessarily forced to engage with flag planting work just because it exists. Some of the things about the LLM wrapper paper of just exploring AI for X, I understand the critiques, but there's plenty of industry folks that are also being like, AI can do X. And sometimes research can provide an important counterpoint and balance to it. And so it sometimes is actually worthwhile to do an LLM wrapper paper or AI for X to understand the capabilities of these things too. And then there are, unfortunately, some people that are just like, I don't like them. I'm over them. I'm just going to have a bad vibe kind of going in this. It's challenging to be like an AC on one of those papers because you have to say like, you have to really engage with the work. You can't just dismiss it outright, but it does happen. So this kind of shows you like how messy the review process is and how much luck and timing has to do with it. It's not optimal, but what do you think? What do I think we can do about it from everything that I've seen? And again, this is all my subjective perspective. So these first three critiques about just like language models themselves, I do think it's reasonable to ask authors to just get a sense of how random and arbitrary the LLM responses can be. And this could be done through a sensitivity analysis or a multiverse analysis. It could be something in your supplemental materials just to say like, we thought about it and we have some grounding on it. That could be really useful. I also thought about, I've seen some papers that actually have a budget and access statement to tell you what hardware and what costs you actually need in order to reproduce the study results. I like that a lot. I'll show you an example in a moment. We should really think about that. I also think it's reasonable to actually justify why a language model is needed to solve a particular problem, because sometimes it is. It really truly is, and we have to accept that. Like there's spaces for it where it belongs and spaces where it doesn't belong in. And some of the evaluations are just language models are new and cool and we should use them, and that's not always strong enough. So this is one example of a budget statement from this paper that was just published at Colm. And they actually indicate the cost of just using the OpenAI API for just this one study was about $1,000, which isn't a lot, but again, that's one language model and probably just run once. So this is a really useful budget statement that helps us understand, the equity of this kind of research. For actually looking at existing prior work, there should be some limitations on requiring authors to engage with or cite work that has recently emerged. I'll show you an example from the ACL and AR rolling reviews. I do think we should make better use of the desk reject so that we're not actually overburdening our community when the flag planting papers just like come to Viz and Chi and still actually require a very limited reviewer pool to engage with material that doesn't materially engage with our community. And the last part I'll say is this is underused, but discussion periods are really helpful, especially for these borderline cases or where there are different points of perspective in the review process to bring some of these issues to light and actually to discuss them. So this is an example of the ACL and rolling review where it actually says that work that appears fewer than 3 months prior to the submission deadline is not considered contemporaneous. And so there's different ways you can interpret that and different ways that you're dealing with that, but this is the community actually sort of kind of throwing a bone to the authors and not requiring them to, add the latest language model on the day of the submission. So those are some of my thoughts. Again, the point of this is to hopefully to engage in discussion. I don't think language models are going away. And that's it. Thank you very much for your time.
All right, thank you, Anna. We're again behind on time, but there's a ton of questions in chat. The one I had was, so the trends you identified in the paper are continuing in CHI 2025. I looked at the Viz subcommittee, and something like slightly a third of them are LLM related. And as you mentioned, it's a totally small, overburdened review pool. How do we solve sort of the tactical challenge of there's maybe a half dozen people with the right kind of expertise to meaningfully evaluate these papers, and they're all overburdened with a bunch of other stuff? Is just hitting that desk reject button going to do it, or are there more sort of steps that we can take as a community or as organizers to make things easier on those folks?
I think that there's some ways where CHI is a little bit better about how we can use a desk reject as 1 ACs and 2 ACs, say, compared to the Viz process, where you can desk reject based on content. And so sometimes I do that, looking at as a first pass, whether the work materially engages with anything that's related to Viz, CHI, or HCI. And of course, it's not a unanimous decision where it's just like, sorry, it's not just me making a decision for everybody. There is actually like the 2 ACs and the overall subcommittee chairs also have to agree. So there is a process for this desk reject. But going back to the problem of like 30% of papers submitted are related to LLMs, but you don't have like 30% of the committee that can review it. That's a really challenging problem to address and to solve. Because our work is more application based, I would say that you can still say, like, if you're doing AI for storytelling, like there are people that actually know tons of the storytelling techniques and would still be valid reviewers in our community, even though the work is based on a large language model. We're not necessarily looking at the low-level mechanics in quite the same way that the machine learning community is. And so we might have a little bit more leeway when it comes to skills and stuff like that. But I think this will be a challenge moving forward. I think also as we're requesting people authors to review, that's a huge problem, because somebody that's submitting to our community that knows nothing about our community suddenly being required to be in the reviewer pool is also hugely problematic. So that's my thought, but it's an ongoing process. Is something that we hope we need to continue to engage with. This is not going to be the first new technology that emerges, and the point of this paper was to start this discussion out loud.
All right, thank you. So we have, again, more questions in Slido, but I will move on to the next one since we're running low on time. So this work is Daniel Weisskopf, also from Stuttgart, Bridging Quantitative and Qualitative Methods for Visualization Research, a Data Semantics Perspective in Light of Advanced AI. And sort of very in line with our theme this year about the ability of AI models to augment or change our methodologies in Viz evaluation.
Hello and welcome to my talk on Bridging Quantitative and Qualitative Methods for Visualization Research, a Data Semantics Perspective in Light of Advanced AI. With progress in AI technology, there's already a massive impact on how research is being done. One example is the use of large language models, for example, for analyzing text data in the humanities and social sciences. Another cornerstone is the availability of foundational models for many modalities, including text, image, and video. Multimodal models are of special interest for us, as many visualization studies record such data. So, what is the impact of AI on the next generation of research methods for visualization? And more specifically, how does AI affect the roles of quantitative and qualitative methods? My goal is to bridge both kinds of methods in order to combine their complementing strengths. Let me fill in a few preliminary examples, all based on earlier work where I was involved. These examples are embedded in a large long-term collaborative project that targets research methodology. One method is based on eye tracking. I use it as a starting point for bridging, initially from the quantitative side. I will show that even here, qualitative methods can be super helpful. For example, to improve understanding or provide guidance for empirical research. Let's take this example of a very controlled user study. In this lab experiment, we compared variants of support for visual search in maps. The stimuli and tasks were quite simplified and under strict experimental control. The image shows a typical stimulus. Not surprisingly, we collected a lot of quantitative observations and evaluated them by statistical methods. However, we also needed qualitative investigation to explain and understand findings of the experiment. This attention heat map of the eye tracking data can only be understood when we relate it to the semantics of the stimulus and task. The hotspot at the bottom is at the search queue around the map, and the other hotspot is at the final target of the task. However, the evaluation of the study doesn't stop here. Informed by this understanding, we could arrive at adapted new measures to obtain more in-depth quantitative results as well. The previous example illustrated that we can introduce meaning by including additional sources of data and outside knowledge. Let's now have a look at coding, just to take a typical qualitative approach as a starting point for bridging from that side. Coding becomes even more informative for data-rich observations, but it's also quite challenging there. For example, when combining audio transcripts, video, eye tracking, and user interaction logging. In general, coding can lead to quantitative information again, for example, the frequency of codes. And we add semantics through the coding process. Alright, the previous examples already did some transitioning between quantitative and qualitative methods, but often at the cost of substantial manual work. How can we advance data-rich user studies by putting some of the workload on AI? To this end, I'd like to present a generic process model. It starts, as usual, with a research question. Then we arrive at the study design and execute the study. This leads to often multimodal study data. Now, we take this study data and transform it by observing its semantics, or by enriching it with further semantics from other data sources or outside knowledge. We might do this several times in an analysis loop. Finally, the cycles of the loop will eventually lead to higher and higher levels of understanding. The analysis loop allows a flexible distribution of work to the human analyst and AI. Typically, the lower-level processing steps might be rather AI-based. Simple examples include speech-to-text for audio transcriptions or face recognition in videos. And the processing might include more human intervention and input for higher levels. Also, the process allows grounding by checks in each cycle, which is super important for reliable results. Overall, the process is a collaboration between human and AI. The number of iterations will also depend on the type of study and recorded data. Through the cyclic process, we will see a larger variety of representations, especially for intermediate steps. For example, graphical models, sequences, point sets in high-dimensional space, text, or images. This alone will blur the traditional separation in qual-quant methods. A key point is that the process model is meant to be flexible. It should be adapted to the type of study and data. Just for illustration, here's an example of one cycle of the model. Again, it's for eye tracking data. The goal is to speed up gaze labeling with semantic information. Therefore, computer vision techniques are used. However, the human analyst is still included to check and improve classification results. In this way, we can achieve trustworthy results also with awareness for issues related to uncertainty. More details will be provided in the talk by Maurice Koch later this week. Alright, let's see how evaluation methods could evolve in the future. First, I'd like to point out that bridging qual-quant is especially important for viz research. One reason is the large design space in visualization. Another reason are unconstrained studies like in the wild studies. Here we need to combine the complementing strengths of the evaluation methods. And AI is not only to make existing qualitative research methods faster. We can think of new directions, for example, causality identification techniques to better understand complex studies. We have a large variety of contribution types in viz. Likewise, we should have a large variety of adapted research methods. I think that the flexibility of my process model supports this. A great benefit of including quantification is that it provides a direct way to computation. And this could go beyond just evaluation. For example, we could develop new adaptive user interfaces based on on-the-fly measurements. With the new opportunities, we should also take care of issues related to ethics, data protection, and privacy. Finally, we need ways to evaluate the new evaluation methods. We need human-centered ways of AI-supported visual data analysis for the rich and complex observations for the next generation of studies. I think that our community is in a great position to tackle these challenges. And even better, we are our own domain experts. Therefore, we should do this for this to come up with the next generation of evaluation methods that include human and AI and that bridge qual-quant boundaries. For full reference, here are the image credits for this talk. I'd like to thank you for your attention.
All right, thank you, pre-recorded Daniel. Now let's talk to live Daniel.
Yeah, live Daniel's here.
All right. So one question I had was, right, the notion of sort of using AI to augment, especially this kind of data, right, like augmenting it with edge detection, filtering out iPaths. A lot of that has been established in computer vision algorithms for a while. But I wonder sort of what, if to the extent that we're in a new AI summer, sort of what new capabilities of augmentation are being afforded by these new kinds of models and new scales of models?
I think that's a good question. So my first take, as I also said in the talk, was to focus a little bit more on these low-level things and that are well established. I think in some way we might be conservative in this sense because we want to have reliable results. So if you want to put something completely on AI, I think it will be these more old-fashioned, maybe computer vision, maybe speech to text and stuff like that. But if you look a little bit further, I think it will be the typical VA approach where we include maybe more advanced, more speculative AI technology, but with human checks. And one thing that I mentioned in the paper that I'm really interested in is trying to use causality analysis techniques. Let's say if you have a huge observation, so not the ones that I explained here, but you do a lot of observations, let's say for a typical qualitative study, and you try to make sense out of this, then I think some of the automatic techniques applied to that infer some kind of causality graph could be super helpful. And there has been work in the community, in the Viz community on causality graphs, but I haven't seen anything, for example, for user study data. And that's just one example. So that was kind of the last notion with the Viz for Viz. We should maybe talk to the VDS people and others. I'll bring them in here. A lot of them are here already, but I think there are more that even haven't considered user study data as an interesting source for challenges. So they go out to other communities, but I think something like causality and other identification techniques could be really helpful here for us as well.
All right, thank you. Although I noticed that Kate Isaac suggested it should be called vis-a-vis rather than Viz for Viz, but we will unfortunately have to move on to the next
okay, thank you.
The next talk. But thank you, Daniel. So Aaron is up next. Yeah. And his talk is Striking the Right Balance, Systematic Assessments of Evaluation Method Distribution Across Contribution Types. And as a reminder, this is the last paper in our session, but after this, we will have another breakout discussion to talk about topics both that came up in this session and in prior things in the work. So please stick around. All right, take it away, Aaron.
Yeah, thank you so much, Michael, for the introduction. Yeah. Hello, everyone. I'm Aaron from UNC Chapel Hill. It's an honor to be here and present our work, Striking the Right Balance, Systematic Assessment of Evaluation Methods Distributions Across Contribution Types. I'll be sharing this work on behalf of my colleagues from UNC Chapel Hill, Utah, and Oklahoma. So evaluation is very essential for visualization research, and I believe you all may receive some reviews saying things like you need more evaluations to demonstrate some weakness in terms of something. And we don't even know like how many evaluations are good enough for a paper. And if we have one more, would it increase the contributions of our work, or would that be enough for us to demonstrate the usability? Well, evaluations can provide valuable insights on, for example, how people interpret different encodings from visualizations, how they understand the usability of a novel technique, and how they use and interact with a novel system. While previous work reported an emerging trend of more and more evaluations has been used in visualization research of the info-based papers. Thus, using their results, we can easily predict the future trends using some models. Likely, for example, it looks like to be linear. And if we feed them into a linear model, we assume there are gonna be 39 evaluations. in with 23 based on the previous data. This number seems impossible, actually. Yeah. So we anticipate this previous work may not enough to effectively describe the current trends. And our objective is to summarize the current trend and patterns to understand what actually happened in the community and discuss what can we do in the future to about info-based evaluations. So in this work, we identify these trends through a non-exhaustive survey of the two most recent WIS issues at TVCG, which is WIS 22 and WIS 23. We included in total of 214 papers after removing the theoretical and some WIS papers of all. And we group the papers into the 5 types: application, experimental, system, survey, and technique. We also categorize the evaluation methods into different groups from quantitative, qualitative case studies. And we also have a mixed method here. Well, let's see CLAMS, which is a WIS 23 paper, as an example of the mixed methods evaluations. In CLAMS, they have a single study that you include both one quantitative accuracy analysis and a qualitative Excel encoding in one single study. So we call all those types of evaluations that a single study have both methods, a mixed method evaluation. And let's see another example paper, which is a computational design pipeline to fabricate lensing network physicalization from Sandra at WIS 23. We categorize this paper as a system paper, including one single quantitative evaluation, single qualitative evaluation, plus multiple case studies. And using those categorizations, we extended our results to how those evaluations has been used in each of the type of the papers in the 2 years of WIS. This chart is pretty complex to understand, but I'll simplify it and let's directly go to the insights. First of all, for experimental papers, we can see these papers are likely to have multiple quantitative and qualitative evaluations as a whole. This is reasonable since experimental papers naturally need to understand various aspects of, for example, efficiency of their designs. Let's see an example. This is one of our papers this year called Shape It Up. In this paper, we conducted 4 experiments to understand different aspects of shape encodings in terms of their effectiveness of palace design. And feel free to join the talk on Wednesday afternoon. Yeah. For the other paper types, like survey papers, we found a relatively low number of evaluations overall, and likely to half of them have qualitative interviews. It seems we not necessary to include any evaluations for survey papers, but you may receive some potential critiques for if you don't have any evaluations, like no evaluations could be effectiveness, it's like what we experienced this year. Yeah. And let's see another example of survey paper. In this paper, a qualitative analysis of common practice in annotations. It includes a qualitative encoding for 1800 annotated charts. Also, feel free to join the talk on Wednesday morning. And lastly, we found for some similarity between system, application, and technique papers. While you can see many high bars with different colors here, this indicates these papers can have all different type of evaluations at a very high number. This is also reasonable because naturally we assume those types of papers need to be evaluated. And let's look at Sandra's papers on physicalization last year's WIS as another example. Again, yeah. And thank you, Sandra, for allowing me using your paper many times. Yeah, we categorize it as a system paper, but why not a technique paper? This could be a common case that for these 3 paper types, sometimes a paper within this type could reasonably be similar to another type. Actually, if you submit a system paper to the application track or to the technique track, I think it'd be really hard for PC members to decide whether ship your paper to another subcommittee or not. And based on all those discussions, let's go back to the very early question. How many evaluations are enough? Well, unfortunately, we cannot have a very concrete answer here based on the results because we are not exhaustive. But we may do some very interesting callback and very interesting predictions based on them. For example, earlier we predict there will be 39 evaluations in WIS 23, and you can see the actual numbers of evaluations shown in a blue dot. But you cannot see a blue dot here. So there it is. We need to scroll up and up and up again, and we now see the number of evaluations in WIS 23, which is 327. This is if we look put them together in one chart, we can see it's not linear and it's more likely to be a exponential function for the evaluation trend starting from the early studies. Well, using those results, especially for the 300 evaluations in this 23, we can somehow predict for the future. For example, 10 years later with 34, what will happen if fortunately it goes back to a linear trend somehow? We will have around 583 evaluations on this 34. It seems to be possible and reasonable to review, yeah. But unfortunately, if it goes to exponential again, as what we observed on the earlier, the final number will be 4277. I have no idea actually here how many authors and reviewers we need to handle such a number of evaluations, especially if you're considering the acceptance rate. We're gonna have roughly 16K evaluations in the submission track, which is hard to imagine for me, yeah. But it's actually not that severe because I did a little trick here. Like in last year's with the 27 evaluations from 109 papers, which is around 3 evaluations of each. While with 22, we even have a little bit more, which is around 331 evaluations and 15 evaluations each paper. And also the increase in numbers may not always be a bad thing. It also indicates, the community is growing because we are having more and more papers each year, but we will still need to carefully design for the necessity of evaluations for each of the paper. And we didn't provide a very concrete answer for those discussions, but for future, we want to provide it, and it will be a need for a more exhaustive survey with temporal analysis of evaluation trends, as well as to answer a critique question, that is, how the numbers of evaluations correlates to its actual contributions of a paper. And lastly, this work is made possible by all our authors and is supported by the following ESF grants here. And finally, we only identify the trend and the patterns, but there's a lot more questions that can be discussed under the big topic, evaluations and visualizations. And you may be able to learn more about this topic under our panel discussion on evaluation trends and data visualizations on Thursday morning with our fabulous panelists, Nicholas, Tobias, Ryder, Michael, and Cindy. Join us if you have any interest. And thank you for your attention. I'm going to be free to answer questions.
Great, thank you, Aaron. We have a few questions coming in, but we're a little low on time. I do want to both shout out this panel, and then also I believe it was recorded. Aaron arranged a panel at Viz last year talking about evaluations in the context of design studies, which I think also hits on some of these points. So I recommend that as well. But just one brief question before we transition things over. Your paper is very descriptive, but I almost wanted it to be more prescriptive. Right. So for instance, the chart you shot of different contributions across different paper types, the fact, if I were to think, does that align with, for instance, the prescriptive guidance that Tamara Munzner and others have given about how you should match your evaluation type to the paper type? My answer is, are we doing that? Kind of, not always, some of the time, right? Is that good? Is that bad? Does it show that we need to expand our conception of what evaluations are? Do we need to, are there people that are, making things that are not fit for purpose? So I just want to, like, how would you, you can wave a magic wand and change something about how we do evaluations. What would you change sort of based on this data?
Yeah, actually, upon our very early discussion of these results, we anticipate these summarization, which is, for example, experimental papers can have multiple quantitative and qualitative evaluations. We treat it as somehow a guideline, like we suggest future experimentals to have more than one quantitative and qualitative evaluations. And for example, we suggest future survey papers to have, you cannot have any, but you may have a qualitative interviews like what we discussed here. But a potential things is, as I mentioned earlier, like this is a non-exhaustive survey, and it's really hard for us to actually call it a suggestion for future studies. So in this talk, I categorize these results as an insight of existing results instead of a suggestion for future studies, just to be, reasonably said, something like that, yeah. And to have more of those like future suggestions, I would still suggest to I believe they're going to be more for discussions in this panel, and our panelists is going to have a fabulous set of statement and questions here to discuss. Yeah, I believe. Yeah, thank you so much.
Great, thank you. Unfortunately, we're out of time. I'd love to have longer time with these papers, but I would like everyone to thank our speakers in the Discord. And right now, what I'll be doing is moving over to sort of our next sec. So here, as us finishing up session 4, coming up next will be a breakout link. So we should be presenting this URL in the Discord. I encourage everyone to join. We have 3 topics raised around the research impact of LLMs, visualization design and theory, and then open science practices, which are to touch on the papers that we didn't get to talk about in breakout in the morning. Before I do that, since I think we're running low on time, we won't have time to close the session after. So I'd just like to briefly thank everyone for attending over the course of the day. I especially want a big shout out to our student volunteers who didn't learn that they were running a virtual conference until very recently. So they've really stepped above and beyond to help us put this together. But otherwise, thank you all for participating. As a reminder, this is a biannual workshop. So our next BELIV is 2026, which should give you all hopefully plenty of time to think about what papers you would like to present next. So with that, thank you all for your attention. I will see you all in the breakout sessions.